Now welcome my students. Today we start our class with a silent prayer. Conduct a silent prayer. Thank you. Now today we are going to discuss the JEE Main September 3 Shift 1 Physics. Our first big question. Question is there and you already have seen the paper and therefore the data are there with you. You say a screw gauge of pitch 0.1, pitch is given. And the number of division on the circle scale also given to you. Therefore, least count is given by pitch by number of divisions on vernier. That on substitution, all the data are there. Pitch is given as 0.1 and number of division is 50. This one calculation is equal to 0.002. And now we are measuring using this instrument having least count this much. We are measuring the thickness of the body and which one is correct. Definitely, the end results must be in the multiple of these two. It can be 0.002 or 0.00, and the point is 4, or it can be 6, it can be 8, or it can be 0. Now you can see that out of that, or there is only one option. The end result is equal to 4, and that is option is 3. Therefore, the result is 3. Now come to the next question. The magnitude of magnetic field in SI at the center of a hexagonal shape coil of side 10 and 50 turns carrying current. Now you know we are taking out of the hexagon that is there with you like this. We are taking only one segment of this. A large one I am drawing. This one like this. Now side 10. Well, now the length of the side is 10. And this is the altitude. And altitude is given by root 3 by 2e. And that I am going to calculate as r. R is equal to root 3 by 2 into a is equal to 5 root 3. Centimeter. Now I am doing centimeter. Into 10 raised to minus 2 meter. That is the value of r. And what is the magnetic induction produced by this segment at this point? And definitely suppose the current is like it is invert. And how much is the value? The magnetic induction due to this one is given by magnetic induction due to this single rod at the central point. At the central point is given by 0 by 4 pi. Our formula I am writing I by r into sine theta 1 plus sine theta 2. Now you can see that here this theta 1 and theta 2 are the same, and that is equal to 30 degree. And r you already found out. Therefore, that is equal to v due to 1. Due to 1 is given by mu 0 by 4 pi. The current through the coil is given I. Therefore, R is given as root 3 by 2e. That is equal to 5 root 3 into 10 raised to minus 2 meter. I by R. The sine theta 1, sine theta 2, both are sine 30. Sine 30, 1 by 2 plus 1 by 2, that is equal to 1. 1 by 2 plus 1 by 2. This is due to this. Now you can say there are 6 such contributions. All are in the same direction. Therefore, the total induction is into 6. And how many number of turns are there? That is in the given, that is equal to 50. Therefore, final answer is equal to, final answer B is equal to 50 into 6 into due to 1, that is equal to mu 0 by 4 pi I by, I is equal to I by 5 root 3 into 10 raised to minus 2 into 1. Now you have to calculate. Calculation in this paper, it is found that the numerical calculation is found to be a little bit difficult. We have to do all this without the help of any other aid, and therefore it is time consuming. 5 root 3 instead of root 3, you have to write 1.7, and multiplication and simplification must be done and get the answer. And doing this answer, the answer is going to be 550 root 3 times u0 I by pi into u0 I by pi. Therefore, the option is equal to 50 root 3, and hence the option is equal to 2. Come to the next question. Here, we are given, going through the problem, a moment of inertia of a cylinder of mass m, length L, radius r about an axis passing through center and perpendicular, that is given to you. If such a cylinder is made for a given mass, our mass of the material cylinder is the same. The ratio of L by R for is a minimum possible I. The moment of inertia is I. How we have to construct that cylinder so that what is the value of L by R? You have to find the value of L by R for which the I value is minimum possible. Now the mathematical condition. So you have to write out first of all, we have to say what is the value of I. I is given to you. I is equal to moment of inertia is given by m into R squared by 4 plus L squared by 12. Now this I am going to say is a function of R, and therefore differentiating di by dr. Di by dr on finding, and the first derivative must be 0 for minimum condition. That is why I am differentiating. Di by dr, if I do m into r is equal to 2r by 4, variable is r, plus 2l by 2l into dl by dr. And this on simplification is equal to m into, there is no need of keeping m. It's equal to 2r by, it's equal to this one cancel is equal to r by 2 plus this one L by 6 into dl by dr. And that is di by dr. And we have to equate that is equal to 0 to have the minimum possibility. But this dl by dr term must be replaced, for which we know that the mass of the cylinder, again it is given that mass of the cylinder is a constant. Therefore, mass of the cylinder is given by, so mass of the cylinder m is given by cylinder pi r squared into L. It's a constant. And differentiating this with respect to R. Differentiating this with respect to R. What is the data that you are going to get? It is said that. Therefore, m dm by dr, if you do. Dm by dr, if you do, you get dm by dr is equal to pi into 2r into L plus pi comma 2r into L into r squared into dl by dr. First term L into r squared differential that is equal to 2r plus r squared into dl by dr. That is dm by dr. But it is given that m is a constant. Therefore, dm by dr is a 0. Since it is m is a constant, therefore this is 0. From this, if we arrange, what you are going to get is that 2r into L equal to minus r squared into dl by dr. 2r into L is equal to r squared into dl by dr. Now, we have to replace what there? We have to replace here dl by dr. Here we have to replace dl by dr. dl by dr on doing here, this will cancel out. dl by dr is equal to minus 2l by r. dl by dr is equal to minus 2l by r. Now substitute here. Therefore, m into r by 2 plus l by 6 into minus 2l by r. This is minimum. I must be minimum. Therefore, the left hand side must be 0 for minimum condition. For minima, this is equal to 0. From this, what do you get? R by 2 is equal to R by 2 is equal to L squared by 3R. And what is the required there? L by R ratio. L by R ratio is required. So take this into this side. So L by R is equal to root of 3 by 2. Root of 3 by 2, that is equal to option 1. So earlier question was simple. Second question was somewhat difficult or moderate, or not difficult, moderate. Now this one is a little bit difficult because we have to do mathematical operations we have to do, and that's fine. Next question. Now here charged particle, charge 1 microcoulomb is moving with a velocity and in an external magnetic field in a region of where the particle is moving, then the force F is given. Then what is the value of F? You know, basic formula for F is given by when a charged particle move in a magnetic field, perpendicular to it is given by, or in a field, Q into V cross B. Now here Q is equal to 1 microcoulomb, 1 into 10 raised to minus 6. Then we have to find V cross B, and V is given to you. The velocity of the particle is given with the velocity 2y plus 3j plus 4k cross. B is given the 5y plus 3j minus 6k. And you have to do simply the cross multiplication on this one. That is what we require. And what is the method? That is, if you write V cross B, it's equal to I, J, K. IJK, V cross B 2, 3, 4, 5, 3 minus 6. Now you simply multiply. Simply multiply into 10 raised to minus 6. This product value into 10. Now that computation I am not doing, which is so familiar to you. You can do this and get the answer. And the answer is found to be 3, option 3. This one doing, the value is equal to 3. Now come to the next question. It is, if you analyze, it is a straight away simple question. Whether you know the cross product of two vectors, that is all what is required. Now next question. Two isolated conducting spheres S1 and S2, radius 2 by 3 r and 1/3 r have 12 microcoulomb and minus 3 microcoulomb charges respectively. They are a large distance from each other. They are now connected by means of a conducting wire a long time after the equilibrium is settled. The charge on S1 and S2. Now, suppose this is our S1 and the radius is equal to 2 by 3r. And this is our S2 and radius is equal to 1/3 r. And in the case of a spherical body, radius is the measure of its capacity, 4 pi epsilon 0 r. And therefore, for convenience, I am going to say this is 1/3 r and this is 2/3 r, mean the radius of first one is twice that of the second one. And therefore, if I say, see the capacity of the second one, radius is the measure of its capacity. If see the capacity of the second one, the capacity of the first one is equal to 2c. This is 2c and this is c. Now we have got two capacities like this. This is 2c and this is c. And what is the individual charge 12 and 12 microcoulomb on this one, 12 microcoulomb, and the other one is equal to minus 3 microcoulomb. When they are coupled, the total charge in the system. Now we are going to couple them. it is joined, and after some time, after a long time, it is a question. So on coupling, what happened? The net charge in the system is algebraic sum. That is equal to Q1 plus Q2. If you do our total charge in the system is given by Q1 plus Q2 is equal to 12 plus minus 3 is equal to, this on doing is equal to 9 microcoulomb. This is the total charge after sharing. That charge now going to be shared among these two capacitors. Now the total charge after sharing going to be shared among them as per their capacitance. Therefore, what is the charge on the first one? Charge on the first one is equal to total charge 9 into fractional capacitance of that capacitor. That is equal to 2 by total capacity 3. This on doing 6 microcoulomb. Remaining charge will be on the other one. That is equal to 3 microcoulomb. So charge of the question is that the first one has got 6 microcoulomb and the second one has got 3 microcoulomb. And therefore the option is equal to 3. Easier question. Next one question now. A uniform rope of length 12 meter and a mass 6 kilogram hung vertically from a rigid support, and a block mass 2 kilogram is attached at the free end. A transverse short wave train of wavelength 6 cm is produced at the lower end of the rope, but the wavelength of the wave train in centimeter when it reaches the top. Now, if you draw the figure is like this. This is the rope having got its mass, and the mass of the rope is given 6 kilogram, and block at the bottom 2 kilogram. 2 kilogram. This one has got 6 kilogram. Therefore, what is the load at this point? The load at this point is the load that is on the 2 kilogram weight. Here it is 2 kilogram weight. Whereas at the supporting point, the total load is the load of the rope plus the mass attached, that is equal to 8 kilogram. Here it is 8 kilogram weight, and here it is 2 kilogram weight load. Now, when a pulse is generated on the system, frequency remain the same. When pulse is generated, frequency remain the same for the pulse. Velocity wavelength change, but frequency remains the same. Now, on a tensed rope, when a wave is set up, now what is the frequency equation? C by lambda. And what is C? The velocity, or V by lambda. Instead of say V by lambda. Where V the velocity is going to be root of T by M. But T is that, so it's equal to 1 by lambda the root of T by M. In our problem, frequency remains the same, the pulse is the same. Well, nu is a constant. M, the linear density of the rope remains the same, that is also a constant. Therefore, the relation connecting lambda and T, nu is a constant, M is a constant, therefore you can write in our problem, lambda proportional to root T. Yes. Lambda proportional to root T. Now the problem is so simple. At the bottom, the wavelength is given, lambda is given. How much is that? 6, I think, 6. At the bottom, therefore 6 proportional to tension there, that's equal to 2 kilogram weight. When the same wave reaches here, the wavelength is us, I don't know, that's equal to lambda dash. Proportional tension there, that's equal to root 8. Now divide lambda dash by 6 is equal to root of 8 by 2, that's equal to 2. Therefore, lambda dash is equal to 12. So the option is 4. Now, moderate question. Straight away question, moderate. Sorry. Yeah, black. Now comes a 750 Hz to 20 ohm RMS. Source is connected to a resistor 100 ohm. And inductance so much, the capacitance so much, all in series. The time in which the resistance heating capacity 2 joule per degree will get heated by 10 degree. Assume no loss of heat. I'm not doing the figure is not needed. In the problem, what is required? We have to calculate the time. For what purpose? To heat up a coil by 10 degree. It is given in the problem. Here you can see 2 joules required per degree. 2 joules. Then to heat up this 10 degree, 2 joule per degree, then heat up that coil. Suppose this is the coil. To heat up this coil by 10 degree, how much is the heat required? Heat required is equal to 2 into 10. Per degree 2. 10 degree 2 into 10, that is equal to 2. Therefore, heat required H is given by, or Q is given by, or H is given by 2 into 10. It's equal to 20 joule heat required. That is the required amount of heat. And who is the one generating that? A coil. And in which AC is there. Now, but you know, heat H is given by I squared R. And what is required there? Time. So, time T is equal to heat by I squared into R. Now, heat required is given 20. I, time may let it be there itself. R, the coil resistance is given 100. Our task is now to find out what is the current through I. Now, I is given by V by Z, because it's AC. V by, here what is Z? Z is given by, what are the components there? The components there, that the component here is equal to a resistor is there. Therefore, Z is given by R squared plus XC minus XCL whole squared. That's the value by VRMS by. Now, R is given as 100. And what is XC? X is equal to 1 by C omega. 1 by, the capacity value is given 10 micro, 10 raised to minus 6. Into omega. Omega 750 hertz. Of omega is given by 2 pi nu. So 2 pi into 750. A 3 O. Then what is XL? L omega. L is given. L is equal to 0.18. Here L is there. It's equal to 0.1803 into omega 2 pi N. 2 pi to 750. O. Now what we have to do? We have to, and V. V is here is equal to 20 volt. Now we have to substitute here 20 by. I am not writing all these things. R is there, X is there, XL is there, V is there. Now you have to compute the value of I using the relation. Now without the aid of a device, how we can solve this? It is very difficult. Very difficult, not possible I think, to get the answer without the help of a logarithm table or a calculator. But you have to get the answer I. So once you get the value of I, substitute here and get the value of time. And then I did with the help of a calculator and I got the answer. And the answer is found to be 348. Option is 3. 348. Now, this is the difficult part of this paper. How it can be done? This calculation can be not easier. And find the root of all these things. And therefore, I rated it as a very difficult question. Theoretical concept is simple, but mathematical calculation is not that bad, not easier. I shall go to the next one. I'm not doing the mathematical calculation of this part because I did that with the help of a calculator. Now come to, in Young's double slit experiment, wavelength is given is used to produce an interference pattern. Wave lambda is given, and when distance between the slit is small d is given, the angular breadth in degree and angular bandwidth. We know linear bandwidth beta is equal to d by d lambda. This is the formula you may remember. And the angular bandwidth, angular beta is given by beta by d is equal to lambda by d. Angular bandwidth is given by lambda by d. Lambda is given. Lambda is equal to 500 nano. 500 nano. 500 into 10 raised to minus 9. Lambda. D, the separation between, that is given 0.05 into 10 raised to minus 3. Now, this one simplification. This one simplification you can get. It's called 5 into 10 raised to minus 7 by, this is equal to 5 into 10 raised to minus 5. This is equal to 10 raised to minus 2. It's equal to 1 by 100 radian. And the question is not in radian but in degree. Convert that. So our answer is the angular bandwidth is given. Convert that radian. So this answer is radian into degree 1 by 100 into, and the conversion ratio you know that 180 pi radian 180 degree. Therefore 180 by pi. 180 by pi, so much degree. This on calculation is 0.57 and the option is 3. Again, physical concept is not that much difficult. Physical concept is good, simple. But this mathematical calculation is not that much. Time consuming, is okay. So, moderate I am telling. An elliptical loop having a resistance R and semi-major axis A and semi-minor axis B is placed in a magnetic field. In the figure, if a loop is rotated about the x-axis, about this axis rotated, angular frequency omega, the average power loss in the loop due to average power. You know, the flux pi is gone by, there is only one term. So B dot A is equal to B A cos B dot A. Okay. B dot A. Only one term, that is why. It's equal to B A cos omega. Cos theta is equal to cos omega. It's a rotating coil. And therefore, induced EMF is gone by minus d phi by dt. Induced EMF minus d phi by dt. And this is equal to minus B A omega. Now differential of cos minus sin omega t. So that becomes plus sin omega. So this is B omega sin omega t. So okay. Now you got induced EMF. And what is the peak value? B n omega. Peak value. RMS value B n omega by root 2. That is the RMS value. RMS, ERMS is given by BAN omega by root 2 volt. Now the question is the average power loss, and the power is given by square, ERMS square is squared by R is equal to, this one doing, B squared A squared omega squared by 2 into R. This is the power. Now, here A is the area, that is an ellipse. For an ellipse like this, semi-major and semi-minor axis are given. Therefore, area A is equal to pi AB. Area. Now substitute here, and get the answer. That's equal to B squared into pi squared A squared B squared into omega square by 2. And compare and get the answer. Compare and get the answer. And the answer is found to be 2. The answer is 2. Come to our next question. And the earlier question, moderate question. That's it. Question number 10. In a circuit shown in figure, the total charge given 750 microcoulomb and the voltage across the capacitor C2 is 20 volt. then the charge on the capacitor C2. Now, coming to this, here circuit is like this. Now this circuit. In our figure we are given C3 is equal to 8 and the voltage drop across here, that is 20. Therefore, what is the charge on C3, which I am going to call as Q3? The charge on C3 is equal to CV, and therefore that is equal to 8 into 20, because the voltage here is 20 volt, it is given 20, therefore 160 coulomb. That is the charge here. The entire charge in the system, that is given 750. The total charge is given in the system, given you as 750 microcoulomb. Now see, in series combination, here there is a capacitor and here there is a combination capacitor. So combination capacitor. And charge on this one and this one are the same, and that is equal to total charge. Charge on this one and this one, because in series charge remains the same. Therefore, in this and entire system, this one, the total charge is 750. So charge on this one is 750 microcoulomb and charge on the entire one is 750 microcoulomb on this one. Out of this, the charge on this one, in this, now we come to this subsystem. In this subsystem, the total charge is 750, but the charge on this one alone is 160 coulomb. We already calculated, microcoulomb, we already calculated. This one, the total is 750 microcoulomb. Therefore, what is the charge on this one? That is the question. The charge on this one is equal to our answer charge is equal to total charge in the subsystem, that is equal to 750 minus charge on this one, that is equal to 160. And substitution you get is equal to 590 microcoulomb. And therefore option is 4. Option is 4. Simple question. Our grade as a simple question. Now question number 11. Consider a gas of a triatomic molecule. The molecule has assumed to be triangular and made of massless rigid rod whose bodies are occupied by atoms. The internal molecule of the temperature T is. Now see, in the figure if you look, it is a triatomic non-linear. Triatomic non-linear, and we are not considering its vibration. Good. Then the question is, what is the degree of freedom for triatomic non-linear? That is 6. Our degree of freedom that you got, degree of freedom of this, because it's triatomic non-linear is 6. And what is the energy? Energy is equal to our formula N by 2 RT or F by 2 RT. F by 2 RT. That is equal to 6 by 2 RT. Is equal to 3 RT. Very simple question, and option is 2. Next question, question number 12. Pressure inside 2 soap bubbles. Total pressure that is there. 1.01 and 1.02 atmospheres respectively. Then the ratio of the volume is. Now is the total pressure. Therefore, what is the excess of pressure? Excess of pressure is given by here 1.01 minus 1 is equal to 0.01. But excess of pressure in the case of a bubble is given by, what is the formula for excess of pressure is equal to 4S by bubble, it is equal to 4S by R. Therefore, here I can write it is equal to R1. Therefore, R1 is equal to radius of the first bubble. The radius of the first bubble R1 is equal to 4S by 0.1 R1. And in the case of a second bubble R2, the second bubble, first bubble. In the same way, but the excess of pressure is 0.02. Therefore, R2 is equal to 4s by 0.02. R1 and R2 both the bubbles are given. Now the question comes to that is what is their volume? Volume is given by proportional to 4 by 3 by RQ. Therefore, V1 by V2, that is what is asked. V1 by V2 is equal to R1 by R2 whole cube. If you do substitute here, R1 by R2 is equal to 0.02 by 0.01 whole cube. Equal to 2 whole cube is equal to 8. So the answer is 8 is equal to 1. Option is 2. Again, straight away question. Not much difficulty. Question number 30. A satellite is moving in a low, nearly circular orbit around the Earth. The radius is roughly equal to that of the Earth radius, RE. By firing rocket attached to it, its speed is instantaneously increased in the direction of its motion so that it becomes √3 by 2 times larger. Due to this, the farthest distance from the center of the Earth that the satellite reaches is R, then the value of R. Now suppose this is Earth. Radius R, I am going to RE, radius. In the beginning we can say that it is doing circular orbit, or it is assuming circular orbit, very nearer to the Earth, like this. This is it is revolving. Or radius of the orbit is same as that of the radius of the Earth. Then what is the velocity now? The orbital speed. Orbital speed of the satellite V1, if I say V1, first case V1 is equal to root of GM by R. Velocity now, the orbital speed now is equal to root of GM by R. It is doing circle. Now what in the problem says? When it was here, say a booster rocket is operated so that its speed is increased. How much times? It is given that √3 by 2 times. So when the booster rocket is switched on, the speed of the satellite at this position, which I am going to call as A, position A, there the speed now become √3 by 2 times. Root of 3 by 2 into V1 is equal to root of 3 by 2 into root of GM by R. This is the speed now. Due to this, what happened? The path changes and the rocket will assume an elliptical orbit like this. Now, this is the apogee of that elliptical path, we can say. Now, question is, due to this, the farthest distance from the center of the Earth to satellite reach, this is R. And what is the value of R? In terms of R, this is the question. So now here it is, where since it is now taking an elliptical path, at the apogee region, speed is minimum. So here V is minimum because it is elliptical path. At the apogee, speed is minimum. Now we have to find what are the conserved system in this satellite motion. There are two things we can say conserved. One is angular momentum conserved. And now we can apply the angular momentum conserved. Second one, total mechanical energy of the system is conserved. So total mechanical energy conserved. Therefore, you can say the total energy here and here are the same. And what is the total energy there? Gravitational potential energy. Our total at A, our total, that is mechanical energy at A is equal to total mechanical energy at B. Now we have to compute. And what is the mechanical energy there? Potential energy minus G capital M satellite mass small m by RRE plus kinetic energy half m into what is the velocity here, that is we wrote down velocity now is equal to root of 3 by 2 into root of em by RE whole square. This is the potential energy, then it is the kinetic energy at this location equal to the total energy there. The total energy there is also again the gravitational potential energy, that is equal to minus G capital M small m by R, where R is required, plus the kinetic energy. Kinetic energy is equal to half m V minimum square, because that is the apogee region. Equation number 1. So total mechanical energy conserved, that we applied, and you got one equation in which there are two unknowns. And what are the two unknowns? V minimum is an unknown factor, and R, that is also an unknown factor. And therefore definitely, since there are two unknowns, we are going to equations. And therefore next equation is angular momentum conserved at the angular momentum is conserved. That is angular momentum L at A equal to L at B. Angular momentum symbol L. L at A is equal to L at B. And what is the angular momentum here? mvr, that is our formula. Therefore m into velocity there is equal to this one. Root of 3 by 2 into root of em by RE into R. mvr, that is the angular momentum here. And angular momentum here, consider what is the angular momentum there? That is equal to m into velocity there is equal to V minimum. M into V minimum into R. R is equal to R. Question number 2. Now we have got two equations and two unknowns. Two equations and two unknowns, and therefore now you are in a position to solve R as well as V minimum. Both can be asked. Here R is, I am not going to do, because this one is the toughest question, concept wise as well as calculation wise. Or you can consider this as, or you can accept this problem as a problem there for JEE Advanced, not for mains. That much time is required, physical concept is required in this problem. Now solve 1 and 2. We get, I'm not doing, we get R as well as V minimum. If it is asked, both can be calculated. If you solve, the value of R is obtained to be 3RE. When you do that calculation, the calculation part alone is there, that is a simple one, and not a simple one, time consuming definitely, and therefore do and get, and the value of R is found to be 3R. That's correct. But the toughest question, one of the toughest in this, toughest, not the difficult, I say toughest question, concept wise as well as mathematical simplification part also. Next. Radioactive material, fraction of radioactive material remaining after 9 by 6. The fraction that remain after T by 2. You know, the formula you may remember, n by n0 is equal to 1 by 2 raised to n. N by n0 in the first case is given. And therefore, what is the value of n in the first case? N by n0 first case. In first case, n by n0 is equal to given 9 by 16, and n is T by T, where N is equal to number of half-life in given time. N is number of half-life in given time. That's what T by T, that is given. And the question is the fraction that after T by 2, that I don't know. I mean, second case means after T by 2 time. This N by N0 I don't know, I am going to say that is X. X is equal to 1 by, at the second case after T by 2, ratio N by N0 or N dash by N0 we can call as X. X is equal to 1 by 2 raised to. And what is the value N now? There is N dash in second case. N dash is equal to T by 2 by T is equal to 1 by 2 into T by T is equal to 1 by 2 into this N. Therefore, what is I can write that is X is equal to 1 by 2 raised to N dash is equal to 1 by 2 raised to N dash. N dash is equal to 1 by 2 N is equal to 1 by 2 raised to N raised to 1 by 2 root. And what is the value of N? T by T, earlier N. And 1 by 2 raised to N, that is our 9 by 6. In the first case, 1 by 2 raised to N is equal to 9 by 6 is equal to 9 by 16 all raised to half is equal to 3 by 4. Therefore, in second case, N dash by N0, that is our X is equal to 3 by 4. 3 by 4, option is 1. Definitely moderate questions. Okay. 15. A model torch battery of length L be made up of a thin cylindrical bar of radius A and a concentric thin cylinder shell of radius B filled in between with an electrolyte of resistivity ρ. If the battery is connected to a resistance of R, the maximum joule heating in R will take place. First of all, we can come to the conclusion that the maximum energy when internal resistance of the battery and external resistance are same. That means, in the case of this is the battery, the internal resistance of the battery is equal to R. That is the condition for maximum heat. Our condition for maximum heat is R is equal to internal resistance of the cell. Now we have to calculate what is the resistance of the cell. What is the resistance of the cell? Now for which, suppose this is the inner and this is the outer, and the inner radius is A, outer radius is B. Now take an intermediate segment here at a distance with the radius x, thickness dx. So thickness is dx. An intermediate, if you consider that as a plate, the thickness of the plate is dx. And the area length of the plate is equal to 2 pi x circumference. Length of the plate is equal to L. If you take this is a hollow cylinder and cut that, you get a sheet. And what is the like a sheet like this you got, whose thickness is, this is the thickness dx. This is our L, and this is our 2 pi x. Like a sheet like this. Now, what is the resistance of that sheet or that spherical cylindrical shell? The resistance dr of that shell is equal to our basic formula rho L by A. Here rho is rho. L is the thickness dx. And what is A? A already you know, this is the area. That's equal to 2 pi x into L. There, then what is R? R is equal to integral dr between the limit A to B. It is made up of many number of shells like this packed. Therefore, the total is obtained by like this. It's equal to take this one, rho 2 pi L out, integral dx by x between the limit a to b. This one doing rho by 2 pi L into integral dx by x log x, b by a. Upper limit and lower limit. This is called log b by a. Therefore, get the answer, rho by 2 pi L log b by a. But then rho by 2 pi L log b by a, option is equal to 1. Our option is 1. Question again, difficult to type. Difficult to type questions. Question number 16. The magnetic field of a plane electromagnetic wave B is given. C is given the speed of the corresponding electric field. You know, here if you analyze the B equation, the wave is y plus ct, that is the equation. Therefore, the wave is traveling along the y direction of unit vector in the direction of velocity. Unit vector of direction of velocity of the wave is negative y direction. Our unit vector along that direction is equal to minus c. So the wave is propagating along negative y direction. Therefore, the equation is like this: y plus and minus c. Now the question is, C is given, then the corresponding electric field. And now, what is the direction of the magnetic field? Direction of B is plus I. Now, direction of the point is vector. Direction of a wave, electromagnetic wave, is given by E cross B. Give you the direction of C. So, direction of C, the wave, is equal to E cross B. Here, C direction velocity minus G. B direction is I. Cross a tape. I don't know this one. The unit vector into I must be equal to G. Then what is this? Question mark. Question mark is equal to minus K. Minus K cross I is equal to minus G. K cross I is equal to J. Minus K cross I is equal to minus G. Therefore, our electric field is along the negative z direction. Negative z direction. Next, we have to get what is the magnitude. To get the magnitude, you know, again, C is equal to E by B. Therefore, E is equal to CB. C is equal to given 3 into 10 raised to 8. Into B, B is given there 3 into 10 raised to minus 8. So cancel up 9. So 9 unit. Up it is negative of minus 9. Function is the same sign, independent number and sign, and this one repeated. And what is the direction? Direction is K vector. Of sign 200 pi into y plus ct into K vector. So that is the answer, and therefore the option is equal to 4. Again, moderator type questions. Moderate type question. When a wavelength or radiation falling on a metal is changed from 500 nano to 200 nano, the maximum kinetic energy of the photoelectron becomes 3 times larger. The work function of the metal close to. Now, you know kinetic energy max, Ke max, okay, is equal to H nu energy in incidence, or Hc by lambda, or instead of this we can say Hc by lambda equal to Hc by lambda minus work function. This is our equation. When wavelength of radiation falling on the metal is equal to 500 to now change it 200, the maximum kinetic energy of the photoelectric medium 3. In the first case, we can write K1 is equal to Hc by 500 minus 5. In the second case, K2, the first case, the second case, K2 is equal to Hc by 200 nano, 10 raised to minus 9, 10 raised to minus 9, minus 1. Okay. But it is given that in the second case, the kinetic energy of the photoelectric becomes 3 times. Therefore, K2, instead of K2, you can write as 3K1, 3 times it is. Therefore, K2 is equal to 3K1. Therefore, you can write 3, instead of K3, substituting from equation number 1, into Hc by 500 into 10 raised to minus 9 minus 5 equal to 3K2. 3K2 is equal to Hc by 200 into 10 raised to minus 9. Now, this can be converted into electron volt energy. How? 12.4 by wavelength by 100, that is equal to nano, 500 by 100. That on doing, this will cancel out. Prof is equal to 2.48 electron volt. That is this thing. 3 into 4.8 electron volt minus 5 is equal to this on doing Hc by 12.4 by 200 by 100. 3 electron volt. That is equal to 6.2 electron volt. So this is equal to 6.2 minus 5. Now simply solve and find the value of 5. Now multiply and simply solve and get the value of 5. Simple question. And this on doing, the value of 5 to be 0.61 electron volt. This on simplification, you get the value of 5 is equal to 0.61 electron volt. First of simplification you can do and get the answer. It's okay. 18. When a diode is forward biased, it has got a voltage drop 0.5 volt. The safe limit of current through the diode is 10 milliampere. The battery is 1.5 volt is used in the circuit. The value of minimum resistance will be conducted in series with the diode so that the current does not exceed. Now the circuit is like this. These are no resistance and this is the cell 1.5 volt and here the drop is 0.5 volt. Then by distribution law, what is the drop across this one? 1.5 minus 0.5 is equal to 1 volt. And what is the permitted current in the circuit? 10 milliampere. Now what is the value of this R? Simply apply Ohm's law. R into, apply Ohm's law here, R into 10 milli, 10 into 10 raised to minus 3 is equal to 1. Therefore, R is equal to 1 by 10 raised to minus 2 is equal to 100. And option is equal to 3. Simple question. Now 19. A block of mass 1 kilogram slide with a velocity 6 meters per second on a frictionless horizontal surface and collide with a uniform vertical rod and stick to it. As shown, the rod is pivoted at O and swings as a result of collision, make an angle theta before momentarily come to rest at the extreme. That's okay. You oscillate, it may oscillate. If the rod has got mass 2 kilogram and length 1 meter, the value of theta approximately. Now initial condition I am drawing. Here there is our mass. Here there is the rod, and here our mass. Mass is equal to small m. Move with the velocity v. And this one is at rest. And this mass is capital M and L is length. So mass is capital. Now, due to this collision, this rod about this axis swing and the extremum location as in the problem is marked. The extremum location swinging at the amplitude position. Mass is M, length is L, and this small m now get attached with it. So this small m is now here. And the question is, what is this angular amplitude theta? Now, earlier before collision, you know that this rod was at rest like this. And here there is a mass moving horizontally at a distance L from this axis. And therefore, angular momentum before collision for the system is the angular momentum of our horizontally moving body. The horizontal moving body is small m with the velocity v, and this is the angular separation L, axis distance from mass to the axis, that is L. Then what is the angular momentum? Angular momentum before collision, L, before collision, is better angular momentum I say. Angular momentum before collision. MVR, that is our basic formula. M V into L, because the rod has no rotation. Only this linear moving body possesses the angular momentum, that's called MVL. And during this collision, you know that is conserved. It is conserved. Definitely it must be conserved. This is the angular momentum before collision, MVL. Then, due to this collision, it gains energy, and what is the angular momentum of the same system just after collision? Just after collision. Then what is the angular momentum after collision? Angular momentum of just after collision. It is said that it is stick on it. Stick on it. And there are two bodies. One is the rod and the other is the mass m. And therefore, an omega dash is the angular velocity just after collision. Omega dash, angular velocity just after collision. Just after collision, omega dash. Then what is the angular momentum just after collision? Basic formula, I am inverted comma, I am writing I omega dash. Where omega dash is the angular velocity. What is I? I is the angular momentum inertia of this system. Angular momentum inertia of the system. That system include what? A rod about one end, mass m and length L. Formula about one end is m L squared by 3. So that is called m L squared by 3. That is the momentum inertia of the rod about the central axis, plus mass attached at the end. Mass a particle, you have to consider mass small m at a distance L, momentum inertia is called m L squared. This is the momentum inertia of the combined system after collision, momentum inertia into omega dash. But you know angular momentum is conserved. Since the angular momentum is conserved, what we can write by conservation? Conservation of L. What you can write? L equal to MVL. that is the angular momentum before equal to angular momentum after capital M L squared by 3 plus small l squared by into omega dash, from which if you want you can find omega dash, because in the problem it is given namukku thannirulla data nokka what are the data that is given there. A block of mass small m is 1 unit, small m is 1 unit, v is given, velocity is equal to 6 meter per second, collide with a vertical rod and stick to it. And what is the mass of the rod? Capital M. Capital M is equal to 2 kilogram. This is 1 kilogram. This is 2 kilogram. Now, look at the problem. You are given small m, v, l, everything is given, and substitute you can find the value of v dash, omega dash. If you want, you can find omega dash. Now after collision at the extremum, another problem begins. It is started from here, and at extremum this is the location. Therefore, whatever initial energy, that is rotational kinetic energy, possessed by this one, now become potential energy of the system at the extremum. And here what happened? The block here, the block was earlier here, now here. Therefore, this is rose to a height h1. And what is this h1? h1 is equal to L, if this angle is equal to theta, L minus this distance. And what is this distance? L cos theta. L cos theta. Therefore, h1 is equal to L minus L cos theta. Therefore, the height to which the block rose, h1 is equal to L minus L cos theta is equal to L into 1 minus cos theta. So, what is the increase in potential energy of that block? EMGH. Increase in potential energy. P increase is equal to EMGH1 is equal to EMG H1 is equal to L into 1 minus cos theta. Increase in potential energy of small m. Now, what about the increase in potential energy of the rod? The center of gravity of the rod is at this point L by 2. Now here, therefore, it rose through this much height. This is H2. Here it was earlier here, now the center of gravity of the rod here. So it is tilted through an angle theta, so that is equal to H2. And what is H2 there? L by 2 minus L by 2 cos theta. Therefore, increase in potential energy, increase for the rod is equal to capital M G L by 2 into 1 minus cos theta. Mg into L by 2. Mgh. Here is equal to H2. Therefore, capital M G into what is the rise? L by 2 into 1 minus cos theta. Now, what you can write? Energy conservation. Energy conservation. Now, apply energy conservation. Applying energy conservation. The total kinetic energy conserved. That is, either you can write half I omega dash square or L square by 2I. That is the initial kinetic energy. But now I am going to write half I, that is equal to M L squared by 3 plus M L squared half I omega dash square. Omega dash you calculate. This is the initial kinetic energy is equal to initial kinetic energy, rotational kinetic energy is equal to increase in potential energy. How much is the increase in potential energy? Equal to increase in potential energy for both block as well as the rod. That is equal to earlier one mg small mgl into 1 minus cos theta plus that of the rod, capital MGL by 2 into 1 minus cos theta. Now here we know everything except theta. Now solve and find the value of theta. Now again it is a difficult one, very difficult one. Mathematical calculation is laborious, cannot be done quickly. Time consuming, laborious thing. And mathematical physical concept applied is also difficult. So it is again a difficult group. Now you can say that there are 4 problems, which is laborious and difficult. That is accommodated in out of these 25 questions. You can see 4 questions are very difficult, both wise, that is physical concept wise as well as mathematical numerical calculation wise. Solve and get the value of theta, and theta, when we calculate that, the theta value found to be 63 degrees. The value on calculation found to be 63 degrees. Not easy. The calculation part is not at all, I told you, laborious problem. Next question. A balloon filled with a helium burst. Immediately afterward, the expansion helium can be considered as. Now, what type of? It is sudden, therefore is adiabatic, and the expansion of that is irreversible. Therefore, you can say irreversible adiabatic. The easiest question. Come to the next one. 21. A person 80 kg mass is standing on the rim of a circular platform of mass 20 kg, rotating about its axis 5 revolutions per minute. Person now start moving towards the center of the platform. What will be the rotation speed when the person reaches the center? Now, like this. It was rotating about this and the man was at the ring. And angular momentum conservation. Now you can see there are 3 problems from the same paper based on angular momentum conservation. That much importance given to that chapter. Now angular momentum conservation. When he was there, you know that I1 omega 1 is equal to I2 omega 2. That is the case. What is I1? When man was here, first case, when he was at the end of the rim. What is I1? I1 is equal to momentum inertia of the ring itself. What is the mass of the ring? M, 20 kg, rotate about a rim. Moment of inertia per center is equal to m r squared. So it's equal to m r squared, where m is the mass of the ring and small m is the mass of the man. And man I is the moment of inertia of the ring plus moment of inertia of the man. Moment of inertia of the man is a point mass at a distance r, again m r squared. About central axis. Rim about central axis. It is not a disk. It is said that it is standing on the rim of a circular platform of mass 200 kg, rotating about its axis. So there is some difficulty there. It is said that it is rim. And again in the problem it said that the person now start moving towards the center of the platform. If it is rim, he cannot move towards the center. Therefore, we have to consider that as a disk. This is a circular platform and he is at the periphery. That's all. What that means. He is on the periphery. Then the moment of inertia of and angular momentum consider I1 omega 1 is equal to omega 2. What is I1? Moment of inertia initially. And here there is a disk about central axis m r squared by 2. M r squared by 2 plus the man at the rim, that is equal to m r squared. Here and omega 1. Answer is asked there in a revolution per minute, and therefore I am simply say omega 1. Omega 1 is equal to 5 revolution. About 5 I am not converting that into revolution per second because answer is asked there in revolution per minute. Therefore it's equal to 5. Omega 1. Now when the man moves and reaches at the center, I2. Man is a point mass at the center, not contributing anything towards the moment of inertia. And therefore, the I2 is equal to moment of inertia of the disk about central axis. That is equal to m r square, capital M r square by 2 into omega 2 is equal to what? Now conservation, we can write m r squared by 2 plus m r square into phi is equal to m r squared by 2 into omega. Now what are the data given? Capital M, platform 200. Small m, mass of the man 80 kilogram. Capital R will be cancel out. Here you can say cancel out. There was no need of it. And all unknown is omega 2. Omega 2 can be calculated. Substitute there and get the answer. Capital M, small m, and find the value of omega 2. R squared will cancel out. And this on doing, the answer is found to be 9. 9.00. So the answer is 9.00. Again, I told you it's a repetition because we met 3 questions by applying the concept of angular momentum conservation in the same paper. Now come to our next question. A backlight beaker has got a volume capacity 500 cc at 30 degrees centigrade. When it is partially filled with VM, volume 30 degrees centigrade of mercury, we found that the unfilled volume of the beaker remain constant as temperature is varied. Gamma of beaker and the gamma of mercury are given, where gamma is the coefficient of volume expansion. Then V of mercury in cc is asked. The question is, suppose this is the physical concept that you have to get. This is the beaker and this is the liquid. Water may be the temperature. The volume of this empty space remains the same. It is set. Empty space, same mean. That is found that the unfilled volume means empty space. That empty space must remain the same. That will happen when? How much the beaker expands, that much the liquid expands. So increase in volume is annulled. Therefore, the remaining volume remain the same. This is the condition. So increase in volume. Increase in volume of beaker equal to, this is the physical logic. Increase in volume of the beaker is equal to increase in volume of the liquid. Mercury. Both must be the same. And what is the formula for increase in volume? Therefore, we can say volume of the beaker. V of beaker. Increase in dV is equal to V gamma of beaker into delta theta is equal to V of mercury, the gamma of mercury into delta theta. Because increase in volume delta V is equal to V gamma delta theta. This is the formula employed. This will cancel out. And the question is, we have to get what is the volume of mercury. So volume of the mercury is equal to volume of beaker into gamma of beaker by gamma of mercury. Volume of the beaker is equal to 500 cc. Answer is in cc. Therefore, you have to keep the same unit. In the gamma of beaker, 6 into 10 raised to minus 6 by gamma of mercury, 1.5 into 10 raised to minus 4. Now you have to simplify. That's all you have to get. You can see that this is equal to 10 raised to minus 6 into 100, 10 raised to minus 4, that you will cancel out. That's equal to 30 by 1.5 is found to be 20 cc. So the answer is equal to 20.00. Come to the next question, 20. 3. A cricket ball of mass 1.15 kilogram is thrown vertically up and bowling machine so that it rises to a maximum height of 20 meter above the earlier question grouping. We can say that is somewhat moderate question. Now come to this. 20 meter after leaving the machine, if the part of the pushing ball applies a constant force F on a ball to move vertically, horizontally at distance of 0.2 meter while launching the ball, the value of F. That means the piston we can see. The piston apply a constant force F, and how much distance the piston move? 0.2 meter. The work, what is the work done by that piston? F into 0.2. That work done is given as the kinetic energy to the ball as so that it rises up to a height. Therefore, that is equal to the potential energy. The potential energy to which the ball is increased, or the height with the ball. How much is the height ball rose? It is given 0.5 kilogram, maximum height is 20, therefore mgh. But the mass of the ball is equal to 0.15 into 10. The height into which it rose is equal to 20. From this, F is equal to 0.15 into 10 into 20 by 0.2. That is equal to 20. This is equal to 2 by 0.2. Is equal to 10. And the question is the value of F. The value of F in Newton. That is equal to 10 Newton. Next question. Something wrong with the calculation, I think. Something wrong with the, I'm sorry. Ah, yes. Calculation is wrong. Now you will see that is equal to 15 into all this is 30. Sorry. This on calculation M into G into H. M into G into H on calculation is 30. The numerator, this part is wrong. That is 30 by 0.2. This on calculation is equal to 150. So the answer is equal to 150. Now next question. Now look at an observer can see a small hole on the side of the jar. Radius is given at a point of height 15 centimeter from the bottom. See the picture, it is given. Hole is at a height of 45 centimeter. When the jar is filled with a liquid up to height 30 centimeter, the same observer can see the edge of the bottom of the jar. The refractive index of the liquid n by 100, where n is an integer, the value of n. Now see, this is the beaker, and the diameter is 30 centimeter or radius is 15 is given. And here there is a block of height 50 centimeters. So this is 15. And the radius is also 15. Radius is also 15. 15 centimeter. Now here there is a hole. I say. Here there is a hole. So then directly through the hole, and this height is given 45 centimeter. The problem it is given 45 centimeter. And directly through this hole, a person can see the top end of the rod. Now when it is filled, and the problem it is that when it is filled with a liquid with some refractive index up to 30 centimeter, up to 30 centimeters here. So this is 30 centimeter. He can see the bottom. He can see the bottom mean the path will be like this. So, okay, when it is filled with the liquid. Earlier directly he can see, now it gets refracted from here, and the person can see the bottom of the rod. Bottom of the rod he can see. So this is the path diagram. Now earlier, you know, if you look, you can see that this is 30 and this is 15, and therefore this is 15. And this is a right angled isosceles triangle. Since it's a right angled isosceles triangle, this is 45, this angle is 45, therefore this is 45. If we apply the reversibility, you can see that this is angle of incidence. So I is equal to 45. Then when you see the bottom, this is the refractor ray. When you see the bottom, you can say that this is the incident ray and this is the refractor ray. And then this is R. This is I and this is R. Now we want to get what is the value of R. R is given by, or sin R, it is better. What is sin R? Sin R from this right angle triangle. This is R, the right angle triangle. What is sin R? Sin R from figure, you can see that opposite side. Opposite side is equal to 15 by hypotenuse. This is the hypotenuse. Hypotenuse is equal to 15 square plus 30 square. This is 30 and this is 15. Therefore, root of 30 square plus 15 square. There is sin R. Then refractive index is us. So refractive index N is equal to refractive index small n, it is better small n. Refractive index N is equal to refractive index. Basic formula is equal to sin I by sin R. It's equal to sin 45 by sin R, directly you got sin R. Sin 45 1 by root 2 divided by sin R 15 by root of 30 squared plus 15 squared. Again earlier difficulty comes. Without aid of an arrangement you have to solve that. 1 by root 2 by 15 by root of 30 square plus 15 square. Not easier one. Not at all easier one. And roughly you can get this is 30.5 and solve like this. 1 by root 2 into 35.5 by 15. Again simplify. And divide that value by 100. Whatever value you got, that is our n. Solve this and divide by 100, you get the answer. And the answer is found to be 158. Now this is the value that you have taken. Again the difficulty. Here mathematical physical logic is required. We have to find out the value of I and R from this geometry. We have to evaluate I and R from the geometry. Next, calculation part. Calculation part, here this part is difficult. And you have to get the numerical value. Definitely we get the numerical value, that is not at all easier. Again, this is a tough question. Time consuming part. Now, next question. When a long capillary tube of radius 0.015 centimeter is dipped in a liquid, the liquid rises to a height 15 centimeter with it. The contact angle between the liquid and the glass is 0. The surface tension of the liquid in millinewton. Directive formula. In a capillary height, H is equal to 2s cos theta by r rho g. That is our basic formula. Here theta is given 0, therefore cos 0 is equal to 1. And the question is, what is S? Therefore S is equal to H r rho g by 2. And in the question H is given, the problem H is given, is given that the liquid rises to a height of 15 centimeter. This 15 centimeter, therefore 15 into 10 raised to minus 2 meter. H is given. Or radius of the capillary tube. That is given the point as your radius, 0.15 into 10 raised to minus 2 meter. Rho, density of liquid 900 is given. Meter. G is given 10 meter per second. So all the data are given there. Simply substitute and get the answer for that. Answer is 101. Answer. Simple problem. Simple problem and get the answer. So that finishes our shift 1 paper, and there we met questions. Some of them has got the standard that of IIT main. Some of the questions. And again we met the difficulty, that is the simplification, mathematical calculation difficulty is also there. And therefore totality we can read, we cannot score much because it is so time consuming one.